I've been discussing about this pinpoint only so long. For most of the questions we have marked that lake, stadium, it's all pinpoint, which is a geographical point over which the aircraft has flown. The pinpoint is 7 nautical miles right of track here. So now I position fix myself and I found myself on the chart over a particular hill or something. I'm supposed to be on top of a lake, but now I'm top of the mountain. Now I can go back to the chart, see where the mountain is, see where the lake is, just measure it. I'll get the off-track distance. I necessarily don't have to eyeball it. Right? So here you can read the question again. The pinpoint is 7 nautical miles right of track. We're asked to find track error, what alteration of heading is required to fly direct to B, and what is the drift. Right? So over here, let's do it. An aircraft is flying from A to B 95 nautical miles, and what is the having flown 35 nautical miles, the aircraft is found from a pinpoint 7 nautical miles right of track. All right, now what are you trying to do? So how will you draw the track here? There's no track given in the question. Remember, if you want to put anything here, that's always going to be a track. Any line drawn, you can think this as a ground. Any line drawn on that is a course or the track. So if track is not given in the question, if you can just go scan through it, there's no way by which you can find the track. In that case, you have to assume a track. Right? So in this case, a track assumption is not required. You can just draw a track of your own, but let's assume a track to make it more clear. Right? So you can tell me a track, AB?
090.
Oh, that's a very easy track, huh? 090 degrees. Yes. We'll take a true track here, or let's make a magnetic track because we're actually flying the aircraft, so it's 90 degrees magnetic, right? So we have a 90 degrees magnetic track here from A to B, right? Let me just draw a bit more. You go.
Total distance is between them is 95 nautical miles.
That's it, 95 nautical miles of distance from A to B. Having flown how much? 35 nautical miles. That is kind of 1/3 of that.
Yeah.
What happened?
35 nautical miles. I am right of the that pinpoint. That
Exactly.
Towards the south.
Right. So I found myself over a mountain, as I told you, and now I'm supposed to be on a lake, on top of a lake. So for example, this lake is here. I'm supposed to be overhead this lake if I was on track, but now I found myself 7 nautical miles right of the track, right? So that is 7 nautical miles right here of the track. I found myself here. Now how do I get the 7 nautical mile here? Since there's a proper pinpoint, this is a pinpoint.
Yeah.
I can actually open up my chart. Remember, dead reckoning 1 in 60 is more of a VFR thing, not an IFR. Therefore you have a chart which you have to legally carry. Therefore I find myself over at a town or a lake or something else, a mountain or something, which I can find out on the chart. That's when I pinpoint myself, a position fix myself. Now we open the chart, I find the mountain, I already know where this is because it's already drawn on my chart. Exactly in the way how it looks on the board, you will see on a chart. You have to keep it on your pad, like if you have a pad or your lap, by wobbling with the aircraft. You have to keep the scale on top of that. And remember, since it's a Lambert's chart mostly, the convenience is just a scale will give you the great circle distance. Right, and you can actually keep all the way straight, and then you can measure 7 nautical miles. So since you're measuring it a beam, it's going to be the shortest distance. So anything off that is going to give you a longer distance. And therefore, and not just that, you can assume a right angle triangle just because that you have measured it a beam. Right, beam means perpendicular. Now that is that is how you get 7 nautical miles off here. Right.
Yeah.
Now what is it? What is the track error?
What is that track error?
Yeah.
So
Easy.
we know that track error is 7 divided by 35 into 60.
Basically, track error is the angle between the planned track, which is right here, and the track with the aircraft flew. That is this particular track here. This is what is called the actual track or track made good. Track error is always measured from the planned track towards track made good. Therefore, how can I find track error? It's very, very simple.
That is the distance off, that is by 7 nautical miles divided by
Applying 1 in 60.
distance flown. Yeah, distance flown, that is 35.
The distance off is 7. That's right. Distance gone is 35 into 60.
Yeah, that is 12 degrees.
12 degrees. You see, just by traveling 35 nautical miles, you went 7 nautical miles off. That's why you have such a huge track error. And 1 in 60 is going to be less approximate here, right? We know that. 12 degrees, right? Now tracker is always expressed left or right. What tracker is it here?
It is to the right.
Right, yes, that's it. Alright, so first question answer, that is what is the tracker? A.
That is 12 degrees right.
12 degrees. Remember, be very sure about the right or left, because I'm pretty sure the options they will give you either of both of those with 12 degrees left and right. So be very careful with that. Right. Next is what alteration of heading is required to fly direct to B. Now remember, whenever you get a question on the heading, don't jump straight to the heading, because if you cannot analyze the track, you cannot analyze the heading. Remember, track change is heading change. You have to have track change first. Let's see the track first. What are you asked to do? You're asked to fly direct to B. Right? So from C, you're asked to fly direct to B.
To B.
Right? What is the distance that you think you need to go more? Further?
That is 95 minus 35, 60 nautical.
That is 60 nautical miles. So think about it, whatever said and done, for the same distance of this angle is going to be less than 12 degrees.
Yeah.
For sure. Because you have to travel greater distance. Right? So 60 nautical miles. Now it's, you have to first analyze your track change. So if I don't do anything about it here, let's see what's going to happen. I keep drifting off all the way.
Yes.
Right? This is my track made good, which is,
Yeah.
what is my track made good here? So it's basically
it is 102 degrees.
Yeah, basically 90 is the planned track, measure 12 degrees clockwise, it's 90 plus 20. Sorry, 90 plus 12, which is 102 degrees magnetic. Right? Now I'm supposed to fly overhead B, which means I'm looking at a track change of so much, which I can divide the two to make it much more sensible. First, I have to turn towards left, right, to prevent the stop drift. Now there are techniques where we use that the kind of drift, stop drift and then think over before you make the final change. So rather than drifting further away, why not stop the drift and then think, just in case if you get stuck in between while you fly, right? So that's the first change which you make to stop the drift. Second change is to actually fly direct. Right? How will you find this angle? We have seen that before. It's nothing but the tracker. Nothing much to do here. It's 12 degrees.
It's 12 degrees to the left.
Sorry, to the left. Yes, guys. I just copied it. Sorry. Yeah, left. Right. So what is? So basically, you can see what is this? What is this track? What track are we flying? We're flying a parallel track.
Again, we are flying to 090 degrees.
Right. Yes. So that is magnetic. We don't require this angle if we were just looking at the track, because we know I know I'm flying 90 degrees magnetic. I don't have to have this angle, but since we're looking at the heading here, I need the track change, and that is the reason why I'm bringing up this angle 12 from here to here, right? And how will you find this final part of it, the second part of it?
So this is basically the closing angle.
Very good.
That is going to fly overhead B.
Exactly. The closing angle, parallel tracks, transversal. So how will you find the closing angle? Taking this triangle, applying 160 here.
We know that distance of
Closing angle is equal to distance of by distance to go.
to go. So distance of is 7 by 60 into 60. That is equals to 7 degrees.
Right, very good. So it's equal to 7 degrees. We don't necessarily have to do it because it's over 60 nautical miles. 160 holds true when there is tracker will be equal to, right? So this is going to be 7 degrees.
7 degrees.
The closing angle doesn't have right left thing. It's just talking about the angle at which you're closing, right? Therefore, this is also going to be 7 degrees.
7 degrees.
What do we find out?
We need to find out the total change.
So track change.
Directly to B. Track change, yeah, sorry. So it's like I was flying at 102 degrees and
so 19 degrees of track change has to be made to the left. Now the whole idea is you're asked to find out, what is the question? What alteration of heading is required to fly direct to B?
degrees of 12 degrees of 19 degrees of heading.
That's all. You're not asking to find the actual value of the heading. So the question is just asking you to find the alteration of heading. So the whole idea is whatever track change you have that's equal to your heading change. Track change is equal to heading change. Therefore, whatever track change you have, what is the track change? 90 degrees to left. Therefore, what should be your heading alteration? That also should be 90 degrees to the left, right? So, what is the answer to the second question?
It is 83 degrees magnetic.
Yeah. So that's it. Look at the board. So, what is the question asking you? It's asking you to find out the alteration of the heading required.
it is the decrease of heading by 19.
That's it, 19 degrees to left, because track change is equal to heading change. This is what is asked in the question. Therefore, that is 19 degrees to left. So question number, the Bravo, it is 19 degrees left.
Left heading.
Heading change or heading alteration.
Yeah.
So be very careful with what they're asking. Yeah? Right.
Yeah.
The final part of this, yes, that's the easiest part here. You can tell me what is the drift.
19 degrees left. That is decreasing my heading.
Okay.
Yes, sir. Third question is, what is the drift?
Yeah, that's to find the drift. That's the easiest part of this question.
Drift is the angle between the planned track and the heading in the planned track.
It is the angle between heading and the track. If it is between planned track, it's the planned drift. If it is between the actual track, it's the actual drift.
So we don't know heading.
Oh, that's it. Very good. We're done with the answer. Insufficient data. There is no heading here because drift is the angle between heading and track. And if track is given but heading is given, there's no way you can find the drift unless you assume it, right? Therefore, in this question, there is insufficient
data
in data. Now, why they are particularly asking that question is because it's a very high tendency to put this as the heading. It's 12 degrees, and I have had a lot of students who have done the same thing, where they bring up 12 degrees as the heading. No, heading is always between. The drift is always between heading and the track. It is always heading and track. Keep that in mind. Heading should be there to find the drift. Now, there are cases where the question they will give you just the drift. In that cases, you cannot start with anything. We will see such questions coming up in NDB and stuff, scenario nav, where only drift is given. The aircraft is moving outbound from an NDB or coming inbound to NDB at 12 degrees port drift, 10 degrees starboard drift. That's all. Nothing else is given. If nothing else is given, with one drift, there's nothing much you can do. Right? So now you're forced to assume a heading, and once you assume a heading with the drift, you can find the track. Or you assume a track with the drift, you will get the heading. So in that case, you have to assume one. Right? So that is so the question is also formed in such a way that doesn't matter what you assume, your answer is going to be the same. So we will see such questions over there. All right. Happy with this question? All the